Hi everyone. Today we're going to talk about probability distributions. So we're going to look at certain experiments and figure out how to list the probability of each event happening. Then we're going to get into one of the major types of probability distributions, which is the binomial probability. Okay, we're going to use these to make decisions and figure out how likely it is for an event to occur once or twice or every single time if we do repeated trials. So we're going to start with a warm up. Mr. and Mrs. Smith, very generic last name, a very popular last name, have 3 children. Assuming that the probability of having a boy is equal to that of having a girl, so 50% having a boy, 50% having a girl. How many outcomes are there? So how many different groups of 3 kids could they have? What's the probability of having all 3 girls? And what's the probability of having 2 boys and 1 girl in any order? So I recommend listing the sample space and then counting. Out of all of the possibilities, how many are there? How many of those have all 3 girls? How many have 2 boys, 1 girl? Pause, take a moment to count, and we'll look from there. Okay, so you tried it out. There should be 8 outcomes. We list them all, and hopefully you do it in an organized way. I personally like the probability tree, so at each step, each branch splits into 2 more branches until you have 3 kids, and you'd wind up with 8 branches. Now, the probability of having 3 girls is only one out of these 8. That's 3 girls. So one out of every 8 families with 3 kids has all 3 girls. There are 3 families that have 2 boys and 1 girl. You could have boy, boy, girl. You could have boy, girl, boy, or you could have the girl first and then 2 boys. So if we write out the sample space, we can count probability. Now today we're going to talk about binomial distribution, where an event either happens or it doesn't happen. We can call it a success or a failure, a win or a loss, but binomial means a distribution where each event has 2 possibilities. So let's go back to this 3 child family. Okay, a probability distribution lists all the possibilities and their probabilities. So we're going to define the probability distribution. We're going to figure out the probability that the family has 0 boys, 1 boy, 2 boys, or 3 boys. So using your sample space that you created from the warm-up, what's the probability that the family has 0 boys? What's the probability that has 1 boy? We already did 2 boys. And what's the probability that has 3 boys? So fill this out, see if you can get all the probabilities, and we're going to discuss what we notice, what patterns we see. So in this case, we once again have all 8 outcomes. And the probability of having 0 boys is 1/8 because it's all 3 girls right there. Probability of having 3 boys is boy, boy, boy is only one of them. And then there's 3 cases out of the 8 where I have 1 boy, and there's 3 cases where I have 2 boys. Now, in a probability distribution, all of the probabilities have to add up to 1. They add up to 8/8 here. Because this is the only things that can happen. You have 0, 1, 2, or 3 boys out of 3. This is also a symmetric distribution where 1 boy probability is the same as 2 boys. And we can think about this, 2 boys is the same as 1 girl. So this could also be the probability of 1 girl, and this could be the probability of 2 girls. And then the probability of 0 boys is equal to the probability of all boys, once again, because they're is a 50% chance of boy, 50% chance of girl. Now, this is not a uniform distribution, though. Uniform would mean that all of the probabilities are the same. Each event is more likely. Now, it's much more likely you have one or two boys in a three-child family than you have all boys or no boys. So go ahead and take a look at this spinner. Write a probability distribution for this spinner. So I called the events F for forward, B for backwards, S for spin again, and L for lose a turn. So in each case, each space, each letter, each forward has two, there's two backwards, there's two spin again, and two lose a turn. So these probabilities all add up to 1. And this is an example of a uniform distribution, where each event is likely to occur. Okay, it's not more likely that I spin forwards than spin again, or backwards, or lose a turn. Each one has the same likelihood, even though everything has two spaces, two backwardses, two forwards, two lose a turns, and two spin agains. Now we could also find the probability of unions or complements. So let's go ahead and find the probability of that it's forward or spin again, or the probability that it's not forward. So forward or spin again, there's two forwards, there's two spin agains, so there's 4 total spaces out of the 8, or 1/2 probability. And then the probability that's not forward is anything but forward, so there's 6 of those spaces out of 8, which is probability of 3/4. Now we're going to use this idea of a complement today to learn about binomial distributions. So binomial distributions help us find the probability of binomial experiments. Now what a binomial experiment is when I repeat an experiment, I do multiple trials where every trial has 2 outcomes, success and failure, or success and non-success. We always got to think in each case, are there 2 outcomes? If so, it might be a binomial experiment. Each trial has to be independent of another. So the probability during the second trial can't be different than the probability of the first trial or the third trial or the fourth trial or any other trial. That will define us a binomial experiment. And we're going to look at a few cases. So the trials must be random, they must be independent, and we have to have 2 outcomes. So this is an example of a binomial experiment. Okay, what is the probability of spinning lose a turn exactly 3 out of 5 times? So we're going to spin the wheel 5 times, and I want to know what's the probability that I get lose a turn 3 out of those 5 times, exactly 3. So what I could do is I could list all of the ways I could lose a turn exactly 3 times out of 5, and these other blanks would be anything but lose a turn. Okay, so I see there's 10 different ways for me to lose a turn exactly 3 times. And I could figure out how many different total ways, but that would take a long time if I wrote the entire sample space. So we do it slightly different. Okay, we can use a combination since order doesn't matter. I didn't say I have to lose the first 3 or the last 3 or anything in between. So I can use a combination to figure out that there's 10 ways to lose 3 out of 5. I'm doing 5, choose 3. I then can figure out the probability of a loss. So on any spin, the probability of me losing is 1 out of 4. We calculated that before, it's 2 out of 8. So if I wanted to figure out the probability I lose, and then 2 other things happen where I don't lose and I don't lose, I can do that by independent probability. 1/4 times 1/4 times 1/4 times 3/4 times 3/4. There's a 1/4 chance I lose, and there's a 3/4 chance I don't lose a turn. I can then take and multiply this by the 10 different ways and get an answer. Now, all of this can be covered in the binomial probability formula, but this is how the formula is created. So the binomial probability formula is this formula here. I recommend you pause the video, write it down. It's only for binomial experiments where we have n trials. We want to know exactly our successes, and we need to know the probability of success and then the probability of failure. So we're going to go through some of these. We're going to go through an example so you can see exactly what to do at each stage. So let's look at how this formula is created, doing the same experiment we just did. Same spinner, same lose a turn, exactly 3 out of 5 times. So the first thing we need to know is how many trials we're doing and how many successes we want, or how many times we want this event to happen. It's a little weird to think of lose a turn as success, but that's what we're defining as we want to happen. Success is what do we want to define happening. Now, we also know that the probability of lose a turn is 1/4, and the probability of not losing a turn is 3/4. Those are going to go in for P and 1 minus P. 1 minus P I like to call Q. Okay, and that's the complement. So 1 minus P is the complement of P. And now we can utilize our formula. So 5C3, we have 5 spins and we want to choose 3 of them to be lose a turn. We want the lose a turn, which is 1/4, to happen 3 times, so 1/4 to the third power. And then we want 3/4 to the second power because we want to not lose a turn twice. So we can do 5 minus 3 or also do 2 here. And that gets us our 0.088, which was the same in the last one. But now we can just use the formula if it's binomial experiment. So we found the binomial probability of losing a turn exactly 3 out of 5 times. And now it's your turn. These problems are going to take some time. Write down the information, write down the probability of success and the probability of failure, and how many spins or how many trials are you doing, and how many trials do you want to be successful. Pause the video, take however long you need, and check back when you're ready to see if you got the correct answer. Okay, so now this has replacement, which means we can use binomial experiment because the probability stays the same each time. And here's the answers for each case. We're doing 4 picks. We want 3 green balls. The probability that it's green is 3 out of 5. That means the probability of not being green is 2 out of 5. Then we can put all our numbers in here and get a probability. And if it told us to write as a percent, we could do 34.6%. And same thing down here, yellow, we want 2 yellows. Oh, maybe I changed this to 1 yellow. Looks like the formula I changed it to 1 yellow. So exactly 1 yellow. Because apparently that's what I solved for. Probability of it being yellow, there's 1 yellow out of the 5, which means there's 4 non-yellows. And one more practice for us to try. This throws a slightly complicated concept at you. I want you to think about what's success in this case. Each time, what am I defining as success? Try to find the probability that I only pick red and green balls. Go for it. Okay, so the major concept here is success is picking green or red. So there's 4 out of the 5 that are success compared to 1 out of 5 that is not successful. I want to pick all green or red. So out of the 4 trials, I want to pick all 4 to be green or red, which means I don't want to pick any of these. A nice thing about this formula is anything to the 0 power we learned becomes 1. And 4 choose 4, there's also only one way to do it. So really, this part is what my answer is, and it becomes 0.410 or about 41%. And this is how we use binomial probability to figure out how to do something an exact amount of times. What's the probability that exactly, in this case, 4 red or green balls are going to be picked and no yellow balls? And that's binomial probability.